Welcome to Hardly. Each book is distilled into 3 stories, giving you the key ideas in minutes. Today, we listen to Paulina Rowinska's Mapmatics, How We Navigate the World Through Numbers, in which we probe into the hidden distortions in map-making that shape our worldview. How ancient math solved the mystery of the Earth's size, the intersection of cartography and real-world survival. Paulina Rowinska, a writer, mathematician, and science communicator based in Warsaw, Poland. Don't go away. Hurdley, the editor, will be right back with the story. We're about to dive into 3 stories that show how the hidden distortions of maps influence our worldview, how ancient math unraveled the Earth's true size, and how these skills can be the difference between life and death. In the quiet setting of a university lecture hall, Paulina recounts her first encounter with how maps distort our perception of the world. The stark realization hit her when, as a young geography enthusiast, she noticed that Greenland appeared almost as large as Africa on the flat map hanging in her childhood room. It wasn't until a later geometry class that she understood why. The map in question, Mercator's projection, was designed to preserve angles, but at the cost of severely distorting the size of land masses. It's a map that still supports the north-centric view, making northern countries seem far bigger than they are, she writes. But the problem goes deeper. This distortion shapes the way we view the world, leading us to unconsciously attribute more power and importance to these larger-than-life northern nations. The solution? Knowing that maps aren't objective representations of reality, but tools crafted with specific purposes in mind, we can begin to challenge our perceptions. Understanding this map's bias helps us see the world more clearly, and more importantly, opens our eyes to the biases we might not even know we hold. Once we recognize these distortions, we can choose better maps or simply adjust our perspectives, being mindful of what's gained and lost in the process. This understanding directly connects to the next story, where ancient knowledge challenges another form of geographical bias. Our next tale takes us back to ancient Greece, where Eratosthenes made a groundbreaking calculation that stunned his peers. His task? Measure the Earth's circumference without leaving his homeland. The story of Eratosthenes begins in the sweltering summer of 276 BCE in Cyrene, present-day Libya. He knew that on the summer solstice in Syena, modern-day Aswan, the sun shone directly into a well, casting no shadow. Meanwhile, in Alexandria, to the north, shadows were cast, which gave him the key. By measuring the angle of the shadow in Alexandria and using basic geometry, he calculated the Earth's circumference with astonishing accuracy, even for today's standards. His calculation was off by only a few thousand kilometers, Paulina explains, and he did it all with nothing more than a stick, the sun, and a solid understanding of math. What can we learn from this ancient mathematician? The power of simple observation, combined with a sharp analytical mind, can lead to groundbreaking discoveries. Eratosthenes didn't need advanced technology. He simply worked with what was available, showing us that sometimes the tools we need are already within reach. This story reminds us that, even today, there are many unsolved problems waiting for those willing to look at them with fresh eyes. And speaking of fresh eyes, our final story highlights how maps and numbers can quite literally save lives. In a life or death situation, knowing how to read maps isn't just about understanding geography, it's about survival. Paulina leads us into a chilling story of survival, one that shows the high stakes of misreading a map in dangerous situations. In 1996, climbers on Mount Everest faced a terrifying dilemma. A severe storm trapped several climbers near the summit, disoriented and lost. With visibility close to zero, they had no way of navigating down, relying on maps that suddenly seemed useless. Their survival depended not only on physical endurance, but on finding the right path in a blinding snowstorm, Paulina notes. Luckily, some of the climbers used a mathematical technique called triangulation to estimate their position based on the limited landmarks they could see through the storm. This same method, used in cartography, allowed them to calculate the most likely direction to safety. They survived, but this experience became a sobering reminder that, without proper knowledge of maps and math, lives can hang in the balance. The lesson? In critical moments, our understanding of maps and numbers can be the difference between life and death. This ties back to the importance of how we perceive and use maps in everyday life. While most of us won't find ourselves navigating Everest, we encounter complex systems and data daily, and how we interpret that information can affect our decisions in significant ways. In reflecting on these stories, one thing becomes clear. Maps and mathematics shape our reality, often in ways we don't immediately notice. Whether it's reshaping our geopolitical perspectives with distorted worldviews, inspiring revolutionary discoveries with simple tools, or aiding in survival during dangerous conditions, these stories illustrate the deep connection between the abstract world of numbers and the tangible world we live in. And with every map we hold, there's a responsibility to understand the forces that shaped it, whether they be mathematical constraints or human biases. As the editor of Hardly, understanding these stories equips us for a future where critical thinking and an appreciation for the hidden complexities of maps and data will shape the decisions we make in our globalized world. Each story comes from the most representative real-life cases selected by the Hardly team from this book. Beyond these three, there are 22 more equally fascinating and insightful stories waiting within its pages. If you wish to dive deeper, we recommend purchasing the full book. The key ideas in Mapmatics return to how maps shape our worldview, the ancient math behind Earth's measurements, and the role of cartography in real-life survival. To wrap things up, let's touch on a different, fascinating story that highlights the consequences of misunderstanding maps. In 2017, Boston Public Schools decided to switch out the standard world maps used in their classrooms for an equal area projection. Overnight, students saw a dramatically different world. Africa and South America appeared much larger, while Europe and North America shrank. It's like seeing the world for the first time, Paulina writes, describing the reaction from students. This seemingly simple change forced students to confront the biases they'd unknowingly held their entire lives, based on a map projection that minimized the global South. It was a clear visual reminder that the tools we rely on to understand the world, like maps, are not always neutral. They shape our perceptions in ways that influence everything from politics to economics. This lesson emphasizes that even everyday tools, like the maps in our pockets, need to be critically examined. What other assumptions might we be accepting without question? By challenging these perspectives, we can see the world more clearly and make better informed decisions. In the end, Mapmatics teaches us that understanding the hidden distortions in our maps, learning from ancient mathematical solutions, and applying these skills in both ordinary and extraordinary circumstances are all crucial for navigating our modern world.